Hello everyone and welcome to another Math 1 video lesson. So in our last video, we went ahead and covered evaluating exponential function word problems. But in today's video, we're going to go ahead and jump into week 6. And the first lesson for this week is going to be simple and compound interest. Now, I do know that the packet has quite a lot of information when it comes to this specific lesson. So what I did is I went ahead and condensed the information that you're going to need for the practice problem specifically. So I start you guys off for the lesson with asking this question: what is the difference between simple interest and compound interest? Okay, and I understand that the definition is going to be a little bit hard for you to understand, but that's why I start you. The next thing is going to be we jump straight into the example so you can see what is these two definitions literally mean. Okay, so when it comes to simple interest, this is interest that's paid or earned only on the principal, which is the initial value. Okay, so that means that when we see a simple interest, we're going to see that things yearly get added to our balance, not multiplied. And we know that this is going to represent kind of a linear type of function. Compounded interest, on the other hand, is interest that is paid or earned both on the principal and the interest that has already been paid or earned. So on a yearly basis, you're going to see your account is multiplied. There's a number that's multiplied by it each year. So this is going to follow more of an exponential type of function. Okay, so what does this all mean? So let's go ahead and jump straight into the example. And mind you, this example is going to help you know how to work on the first two questions in your practice problems for this specific lesson. Okay, so example, you deposit $1,000 in a savings account that earns 6% interest per year. Which type of savings account should you use, simple or compound? Okay, so I went ahead and created two tables. Start off in both tables at year 0. T is going to represent the year. Okay, so T, and I'll write a little note of it right here in red. T represents the year. Okay, the principal, this is how much money we have in our bank account and current, like initially. Okay, so the initial amount of money that we're gonna have and multiply the interest by. The interest, obviously, how much money we add on to the principal each year. And this BAL dot is gonna just represent the balance, but I ran out of room. So just so you know, this is balance. So I'll go ahead, just in case you don't know, BALANCE, balance. Okay, so let's start with the first question. So in this first one, this is going to represent our simple situation. Okay, in our simple situation, we know that our year 0, we have $1,000 in our bank account. This is our principal, our initial value, but we need to know how much interest is going to be added onto it. Okay, well, we know that there's 6% interest, right? But we can't represent this as a percentage. We need it as a decimal. So I know that this is just 6 over 100, which is 0.06. What is 0.06? What is 6% of $1,000? Okay, well, that's just 0.06 times 1,000. You can literally plug that into your calculator. So 0.06 times 1,000, you get 60. Okay, so we know that the interest for this specific year is going to be $60. So what's our balance gonna be by the end of this initial year, year 0? Well, it's gonna be 1,000 plus 60, which is just 1,060. Okay, now I already told you guys simple interest is very linear in nature, so we know that probably each year we're gonna just add the same interest, which is $60, right? Our principal from the initial year isn't gonna change. It's still $1,000, right? So what's our interest? It's still gonna be 60. So how much do we add on to our balance from the previous year? Well, 1,060 plus 60 is gonna be 1,120. Okay. What's our interest for year number 2? Well, it's the same thing. That's why if you notice in your packet, we don't add anything to the principal here because we want you to understand that pretty much the principal, the interest is going to be just on that initial principal. Okay, so we add another 60 to our balance from the previous year. So 60 plus 1,120 is going to be 1,180. So you guys kind of get the idea. Each year we're going to add a simple interest of $60. Okay, so it adds the same thing each year. So after that, it's going to be 1,001 or 1,240, 1,240, and then another 60 after that. That's going to give us 1,300. Okay, so by the fourth year, $1,300. So let's go ahead on the other side and compare the interest now and the balance for compounded situation. Okay, so again, for the first year or for the initial year, year zero, we know we're going to have $60, right? We already calculated that from before. Okay, but if just in case, I'll show you guys again. So for the first year, we're going to have 1,000 times 0.06. This is going to give us an interest of 60. Okay, and you can use your calculator to figure all this out. Okay, so what's our interest right here is going to be $60. So what's our balance going to be? Well, 1,060. Now, however, if you notice, this says principal and interest, because when we talk about a compounded interest, we have to add both the principal and the interest when we consider the new interest. Okay, so what's the principal and the interest by the end of that initial year was 1,060. Okay, 1,060. Now I need to figure out the new interest. Well, this is going to be 1,060, right? Times what? Well, what's our interest from before? 0.06. So how much interest is going to be added on to this new year? Well, 1,060 times 0.06 is going to be $63.6. 63.6. So the interest now is a little bit more in comparison to the simple interest. Now we have $63.60. So we add this specific interest to the balance that we had from before, the interest and the balance together. So 1,060 plus 63.6, what is that going to give us? Well, that's going to give us 1,123.6. Okay. The new principal and interest for our next year is going to be our old balance from the year before. So this is going to be 1,123.6. Now we need to know what's the new interest that's going to be added onto this balance for this year. Well, 1,123.6 times 0.06. What is this going to give us? So 1,000. This is 0.6. 1,123.6 times 0.06 is going to give us 70 or 67.4, and we're going to want to round that up because we don't want 3 decimals, okay, for monies. So we're going to say 67.42. So that's $67.42. This is now the new interest for this year. And we add that onto the balance from the year before. And when we add that, we're going to end up getting 1,191.02. And then you pretty much just keep going after that. So what's our new principal and interest? It's going to be the balance from the year before. So this is 1,191.02. And at this point, you could just keep multiplying, on your calculator. So 1,191.02 times 0.06, because we want to know what the new interest is going to be. That's going to give us 71.46. 71.46. We add that into our new balance. So you add that to the new balance, you end up getting 1,262.48. Okay? And if I keep going in the next year, the fourth year, so 1,262.48. What's the new interest for that one? Okay. So 1,262.48 times 0.06 is going to give us 75.75. So $75.75. We add that to our old balance. So plus 1,262.48, and it should give us 1,338 and 23 cents. So 1,338.23. Okay. So now let's do a little comparison. All right. And I can obviously go on to the end, doing like year 5, year 6, year 7, year two, year 5, year 6, year 7, and then keep comparing. But it's quite obvious, okay, that even after the first year, you start making more in a compounded interest situation. And the reason being is because you got to think about it like this when you think about your money, okay? When you go put $1,000 in your bank account, you're going to make the interest only off the $1,000. So $60 each time, only on the $1,000. We add only on the 60. On the 1,000, right? But when it's compounded, whatever you make by the end of that year, we're going to take the interest of all of that. Okay, so if by the end of the year you made 1,060, we're going to take the interest of the whole 1,060. The interest of all of that is $63.6. By the end of that year, you have $1,123.60. So we're going to take the interest of the whole total of that. The total of that. So you can see the interest each year will keep going up and up and up. This is an exponential situation. But the interest here does not go up. It stays the same. This is a linear situation. Okay? So out of the two, which one would you choose, simple or compound? Well, obviously, I would choose the compounded interest because on the long run and on the short run, I'm going to make more money. Okay? So you got to think about it like that. All right? Now, this pretty much does it for this specific type of example. But I noticed that in your practice packet, there's a question that we didn't necessarily give you an example for. Okay? So I want to go ahead and give you the example for that. Okay? So practice problem question number 3 asks, okay, state if each situation represents a simple or compounded interest, okay? And you have 3 of these, and we're gonna do pretty much A and B, the first 2. So this one is A, and this one is B. For A, you have the year, you have 1, 2, 3, 4, ends at 4. And then you have 1,050, 1,100, 1,150, and then 1,200. And they ask you very simply, is this simple or compound interest? Well, you got to know, right? Are we adding something each time? Are we multiplying something each time? Well, this one is very obvious. Each time, what are we adding? We're adding 50, right? And it's the same for each situation. When we go from each output to the next, it's always going to be plus 50, plus 50, plus 50. So we could tell that this is going to be a simple interest situation. Okay, so simple interest. Let's give you another example. So in example B, again, they go up to year 4, 1, 2, 3, 4, but the balance looks a little bit different now. So you have in the first year, for example, 12,600 and 0 cents. Next year you have 13,230 and 0 cents. The next year you have after that is 13,891 and 50 cents. And then the last one you have 14,586 and 8 cents. Okay, so obviously you could tell right off the bat you're not gonna really be adding each time, because if we go from this year to this year, and if you guys remember how to figure out your growth, you just subtract the secondary number from an initial number, first number. So y2 minus y1 if it's growth that is additive. However, if it's growth that is multiplicative, it's not going to work. You have to divide them. So let's take our y1. This is y1. This is y2. So let's take y2 and subtract it from y1. You have 13,230 minus 12,600. If we subtract those, the difference is 630. So if I add 630 to this number, does it give me what they provided? If not, then it's not going to be simple interest. It's not going to be additive. So let's try. So you have 13,230. If I add 630 to that, do they give me the same numbers? Well, no. This is 13,860. This is $13,891.50. So I know it cannot be simple. So it must be compound. But I got to double check and make sure. What am I multiplying by each time? Well, if you guys remember, if I know it might be compounded, then I can figure out my quote-unquote B, right? And you can say that B is just y2 divided by y1. And y2 in this case is going to be 13,230 divided by 12,600. So let's see that this is going to be 13,300 or 230 divided by 12,600. So it seems like each time we're multiplying by 0.05 or 1.05, but we got to double check. Let's check the next two numbers. So we'll call this y3. We're going to divide y3 by y2 to check if it gives us the same number, okay? And I'm just going to do that on the calculator. So I'm going to grab 13,891.5 and divide that by the number that comes before it, 13,230. And that gives us 1.05. So we know for sure this is a compound situation, okay? And that pretty much sums it up for the video. I know this was a very long video, but there was quite a lot to talk about. Please take advantage of the video and have a good day.